Video, we're going to talk about how to graph cubic functions. So a cubic function has a polynomial of degree 3. So you can see here in f of x, the highest degree term is 3. In 1 minus 573x cubed, the highest degree term also has a degree of 3. So let's now try graphing the cubic parent function, which is given by the equation f of x equals x cubed. So we're going to plug in all of these values and figure out these points. So we have f of negative 2, which is negative 2 cubed, which is negative 8. We have f of negative 1, which is negative 1 cubed, which is negative 1. We have f of 0, which is 0 cubed, which is 0. We have f of 1, which is 1 cubed, which is 1. And we have f of 2, which is 2 cubed, which is 8. So if we plot these points on our grid, we have negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. And if we connect these points, we can form the graph of our cubic function. So here's a little bit better picture of the cubic parent function, f of x equals x cubed. So when we describe functions, we can talk about some key characteristics: the domain and range, the intercepts, maxima and minima, and symmetry of the function. So domain is all the possible x values of a function. Range is all the possible y values of a function. So if we look at this cubic function pictured here, we would say that the domain includes all the values of x. So we would say the domain goes from negative infinity to positive infinity, because there are no restrictions on a cubic function. So we could also write this as negative infinity less than x less than infinity. The range also includes all y values, so the range goes from negative infinity to positive infinity, which is negative infinity less than y less than infinity. So we can also talk about the intercepts of a function. The intercepts are going to be any point where the graph crosses or intersects the x-axis. The intercepts will have the form x0. So we have x-intercepts on this graph at negative 1, 0, 2, 0, and 4, 0. The y-intercept will be anywhere the graph crosses or intersects the y-axis. They have the form 0, y. So the y-intercept will be at the point 0, 8. So let's describe the intercepts of the cubic function pictured here. You can see that it crosses the x-axis at negative 1, 0, and then it crosses the y-axis at the point 0, 1. So now we can talk about any minima and maxima of the function. So a function will have a local maximum at a point if the y-coordinate of the point is larger than the other y-coordinates around the point. So when we're talking maxima and minima, we're talking about the y values of the function. Remember that it's not necessarily the highest point on the graph as a whole. That's why it's called a local maximum, okay? If it was the highest point on the whole entire graph, it would be called an absolute maximum. So we can see here at the point A, we have a local maximum, because you can see the y value at that point is a little bit higher than the other y values around it. There are y values on this graph that are bigger than A, but just around this region, we have a local maximum. Similarly, we can have a local minimum. It'll have a local minimum at a point where the y-coordinate is smaller than the other y-coordinates around it. Once again, it won't be the lowest point necessarily on the graph as a whole. So you can see at B, we have a local minimum because B is a little bit lower than the points that are around it. There are other points on this graph that are lower than B, but just within this region, we can see that B is a local minimum. So let's describe any local maxima and minima of this graph. You can see here at negative 1, 0, it has a local minimum because that value is a little bit lower than all the other y values around it. It has a local maximum at 1, 2 because that point is a little bit higher than the other y values that are around it. So we can also have symmetry when we're talking about cubic functions. Cubic functions will have rotational symmetry about a point. So that means if you rotate the graph around that point, it's still going to look like the same graph. So that point is going to be called the center of symmetry. So if you have local maxima and minima on your graph, the point of symmetry will be halfway between these points. So you can see here at A, we have a local maximum, and at B, we have a minimum. So that's why 0, 0 is going to be the point of symmetry because it's halfway between those 2 points. If you don't have a local maximum or a minimum on your graph, the point will be where the curvature of the graph changes. So this is an example of a cubic function where you don't necessarily have a local maximum or minimum. So notice that before this point, okay, the graph is opening down, right? It curves down. Notice that after this point, the graph curves up. So the point where that curvature of the graph changes, that is going to be the symmetry point. Okay, so that's why this graph is symmetric with respect to 0, 2. So in this graph, you can see here that it has a local minimum at -1, 0, and it has a local maximum at 1, 2. So that point that's halfway between them, that point 0, 1 is going to be the center of symmetry. Okay, this graph will be symmetric with respect to the point 0, 1. So now let's try describing the key features of this cubic function. So the domain is going to include all x values. So we'll say the domain goes from -infinity to +infinity. The range includes all y values. So it's going to be -infinity to +infinity. The x-intercepts are going to be anywhere the graph crosses or touches the x-axis. So I have one x-intercept here and another one here. So I have -1, 0. And I have 2, 0. The y-intercept will be where the graph crosses the y-axis. So we have 0, 4. So we'll have symmetry anywhere halfway between a local maximum and a local minimum. So let's look at this graph. You can see that it has a maximum point right here, and it has a minimum point right here. So the point that's halfway between them right here, this point is going to be the center of symmetry. So that is the point 1, 2. So it has a local maximum of 4 at x equals 0, right? Remember, because the maximum value is going to be the y value of the graph. It has a local minimum of 0 at x equals 2. Okay, so that's how we describe the key features of this function. So now you can go ahead and pause the video and try describing this cubic function on your own. So it includes all x and y values, so domain and range will both be from -infinity to +infinity. The x-intercepts, where it crosses the x-axis, it's going to be at -1, 0 and 2, 0. The y-intercept will be right here at 0, 2. It'll be symmetric with respect to the point 1, 1, right? Because you can see that point is halfway between this local maximum and this local minimum that we have. So it has a local minimum at 2, 0 and a local maximum at 0, 2, or we could say that it has a maximum value of 2 at x equals 0, and it has a local minimum of 0 at x equals 2. So in summary, remember, when analyzing graphs of cubic functions, make sure to pay attention to some key characteristics like the domain and range, any intercepts, and the maxima and minima of the function.